So the source is having a impedance of ZZ. Okay, and in the right hand side at the load side, or you can say the antenna is nothing but a load, only one kind of a, so it is having a reactance as well, that is XA, not a impedance. So this ZA, that is combined impedance, it is having a effect of this load resistance, radiation resistance, and the reactance. Reactance is nothing but because of the inductive and the capacitive effect. Okay, so that you all know, so that I'll not going to explain too much in this. So radiation load and load resistance and radiation resistance, I guess 0.48 value it will be there for the dipole antenna, and that too it is not at all confirmed for me, in case I also forgot. So that X is nothing but XL plus XZ, which is the combined effect of the reactances given by the inductance and the capacitance. Okay, so in order to have a maximum power transfer to the source to load, from the source to load, then your reactance should be zero, because it will be purely resistive. And we all know that in case of this antenna, in order to operate, it has to be purely resistive. It has to be purely resistive, then only the Smith chart will comes nearby to 50 ohm impedance, 50 ohm, then only your antenna will operate. Okay, so ZA is equals to RL plus RR plus ZXA. XA will be XL plus XZ, that is the reactance. And once this reactance is equal, suppose in opposite in equal in magnitude and opposite in direction, then it will be cancelling each other's effect. So at that time, our antenna will be purely resistive. Okay. So second, consider this. Again, figure one of the figure. So this is also one kind of source, and then for the transmission line. So this is only the two wire mechanism. So once you have energized these two wires, so because of the free electrons, it will energized. Okay, and because of these charges, it will move down from positive to negative, negative to positive again in this transmission line as well. So because of this, the field will uh, try to generate. Okay, and regarding this fields also, we all know, as you can see in this figure as well, that field will also move from positive to negative, negative to positive. It will move in this way, in this manner. It will form a loop like structure, positive to negative, positive to negative, again it will form a loop. Okay, so in that way we'll form that, since these wires are open ended at the end. So after this wires, these loops will, these field will detach, or you can say this radiated free space wave. So in that time also we'll assume it will form in a loop wise structure, but anyway it is not at all possible. So this field will started propagating. Okay, so this, in this way it will rotate just like a positive to negative. Okay, now I'll consider the effects of radiation, means what are the drawbacks which are associated with the radiation. Okay, and you can consider this as a radiation hazards or a drawback of radiation, like that you can consider. Now further, what are the effects of the radiation, means in terms of longer expose to the radiations, so it will lead to the some memory loss problem, eyesight weakness, and affecting the cell tissues, especially for the brain, because our brain is a very critical part and it can achieve it. And since, if this, if you can think of a higher frequency, when we consider, suppose in 28 gigahertz, suppose in high frequency communication, then what will happen, this wavelength will decrease, because we all know f is equals to c by lambda, which is inversely proportional to the wavelength. So this wavelength becomes shorter and shorter. So at once frequency, these wavelengths will get absorbed by our body, so it will affect too much in that time. So that's why other issues, health issues will be there, like sleep disorder, eyesight weakness, dizziness, like that. And then precautions, what are the precautions we should take? Don't take too much of use of your electronic device like laptops and all phones, because during night time also we are having